Good morning, everybody. So this video clip is being recorded as a supplement for an article that I have just composed for the website of our consulting company, Clio Research. The article in question is titled Technology Ecosystem, and that's what it is all about. I wanted to summarize the technological set and a skill set that is maintained by people at Clio and myself, Sergey Karpov, as a freelancer in chief. In order to demonstrate all these technological components in action, I have put together a system which consists of, as usually, it has a platform as a part of it, and this is our platform. Dependency abstractions, all sorts of core components for hosting gateways, etc. The SQL Server part, domain part, and the bunch of products, some of which are implemented, some of which are in the pipeline. Today, I'm going to demonstrate one component that is already implemented as of now. It's a WPF desktop. I personally have quite a long history working with WPF presentation, and so certain systems and visuals that have been developed over the years were quite elaborate, and I demonstrate them proudly. I think they were pretty good, and they were working very successfully in different companies. The solution structure. We are dealing with a project manager demo solution, and the target, the executable assembly, is project manager WPF. So this is the WPF application, which has main window, and that's about it. And the app, which I will show in a second, and actually has certain interesting aspects in it. Now, as most of the projects that we do, and I prefer sticking to this structure as far as it works, they sit on what's known as core or platform. So the platform in this case consists of two libraries, one of which is core lib or core lib. It is a standard 2.1, .NET standard 2.1 library. It is compatible across other flavors of .NET, framework and core. That's why I prefer to keep it as a standard. And the next library is specialized with the code that's only available to .NET Core 8, and it's called Core 8. Now, the design is domain driven. We have two projects within domain. They actually both also libraries, .NET Standard 2.1, and the project manager model is I think it's .NET 8. So here is a typical DTO class or entity class. It extends, it implements interface iEntity. iEntity interface makes all entities more or less uniform. So there are many functions that we can perform upon specific DTO class, which implements iEntity interface without specifying the particular type of the class. So for example, I can insert this entity into the database table just based on iEntity interface without specifying that this is a project task class. The code that does this database related, data related procedures, it works on the abstraction, with abstraction completely, without going to specific of what else is in the class. Now I will jump over the project manager model that will be described in a little while, directly to the application itself. So it's an executable assembly, and this is the WPF application type. WPF application type, as I mentioned, it contains standard components which are app XAML with a correspondent code behind, CS class, and this is the main window with also some chunk of code behind. So let's take a quick look what code behind there is. To those who are familiar with the projects that are based on ASP.NET Core Platform, this structure of this class would be somewhat familiar because it contains certain components that are usually present in ASP.NET Core systems. And what do we see here? We see that we are initializing a host. Now the host is being built. Now it's being configured. So we add configuration, and we add code that says configure services, and that's a Microsoft term for registering dependency injection container. Here's the big and interesting, or should I say little, but important piece that has to do with dependency injection. So I am registering this type. I'm placing main window into container using this helper function that is called register cascading. What does it mean? It means that the design principle of separation of concerns, or I should say the flavor of that design principle, is the need to know basis, dictates or suggests that each component that is placed into dependency injection container may have its own dependencies that it depends on. Again, no pun intended. But the code at this level, so this is the, remember, this is the final executable assembly. This is the final stop in the dependency tree. So everything else is up dependency tree, and this class not supposed to know any of the dependencies main window may have, or dependencies of its dependencies. Main window depends on view model, for example. View model depends on other services. But we cannot put all dependency registrations here as if we know them up front. Of course we know, but the class doesn't. So application has started, and here is the log. What do we see? We see a normal startup sequence that we are running this assembly. It's targeting this version of .NET Core. It has the set of assemblies that are that went into the system, also listed here. The top two are platform. These are our two libraries, and these are our domain assemblies. Again, one is you can notice that some of them targeting standard and some of them can targeting specific versions of .NET Core. When we examine the content of an injection container, we see that there's a bunch of standard Microsoft extensions. Those are supporting dependency injection, configuration, etc., etc. And we have a set of custom injected services. And here we see that main window that we inject at the beginning is only one of them. And all others are registered with container using the cascading injection. Right. Now it's time to run application, the demo WPF, and see what it does. So this application is built using Syncfusion control suite, which comes for free. So that was my primary consideration for choosing it, because I just need something to build a thing with. It's organized using the drawer control, and this is the drawer button, open slide back and forth, hamburger button, hold it for some reason. So, like typical drawer control has a left hand selection bar or navigation bar, and in this case it navigates through two content panels. The top content panel, it kind of reflects follows the idea of project management. So we have projects, we have tasks. The tasks are associated to projects, and at the other content panel we have static data. So static data would show clients and employees. Clients and employees, the projects and tasks, they are more volatile, they change frequently. The clients and employees change less frequently, so they are considered static data. The projects contain the foreign key columns for clients, employees, accounts, etc., which actually links it with the static data. So if we look here, we can see the employee and the static data employee. This Wilson guy, right here. Why is it Alexandra? I don't know. Now there is a menu. So the next thing to demonstrate is that how we maintain the menu. The menu can add task to project. There is a menu in this grid, add subtask. This grid is not a grid, it's actually a tree. So this is the hierarchical tree control, the way Syncfusion makes it. But this is the grid. They both bound to observable collections, and observable collections consist of editable visual elements, not read-only entities. These two grids are completely read-only, and they bound to collections of read-only entities that correspond directly to database rows. Here, the other feature worth mentioning is the import. I can import projects from Excel, and if somebody was watching carefully, you might notice that the indicator says 0 of 11 Excel project import. 0 of 11 meaning that they are already here. So the importer would not import duplicates. If you imported already one spreadsheet, you can import it as many times as you can. It's not going to go into the collection. And speaking of the indicators, I will kind of stop on that aspect later on. But right now, let me just demonstrate how visual indicator works. Indicators are controlled by view model, so they have nothing to do. There is no code behind or any logic on the executable assembly, which is the WPF application. Everything is in a domain assembly, which is a view model assembly. So view model, if I want to add task, and this project hasn't been saved in the database, which indicated by this database ID column that identity is 0, I add task and I get error notification. So it says, let me show you again because I like it. It says, caramba, cannot add task. Now, also the other function of the of the visual, there is a confirmation dialog. So it's interesting. So I cannot even delete. I forgot that I put this feature in. So I cannot delete unsaved project either. So let me try delete this project. Okay, so we have normal confirmation dialog, project delete. Do you want it or not? Okay, let's not delete it. And that's about it. So this is not a feature daemon. This is actually you can import from CSV file, so that the function is there, but it's not enabled. I don't want to import from different sources, but the import from Excel is here, and it's demonstratable. So that is what it is. It took about 15 hours to build this application. We went through some features of code, and we will go through some other features as we go along. A quick word about my grievances regarding the way Syncfusion is doing its controls. Here is another application. It happens to be Blazor application, but it uses similar technique, and it uses telleric set of controls. So now we see the telleric grid. What's the difference? There are many differences. So for example, this is the way it's much more intuitive. This is the way it adds row. You press the button that says add something something, and then it shows you the row with the fields that are clearly said, that it is quite clear how they can be set up. So these are text fields, and these are numeric fields. Now this is the picker field. So this this field helps you resolve foreign keys. It gives you the selection for foreign keys. So this is the content from another table. This is the row for one table, but it depends. There's a foreign key from another table, and you can place a value from another table. Now, here is the clearly marked button that you have to save this row, or you have to dismiss the changes. Also, it's very clean. This is a delete button. This is the edit button. So the same way you add new row, you can actually edit row. So everything is done in much more clean way from, in my humble opinion, from the user experience, rather than how Syncfusion does things. But again, it is what it is, and I think that this WPF application that I put together, it actually works pretty well. It's kind of quick. It has a seamless communication with the database, and it implements most of the feature that you would expect from your regular CRUD WPF application that sits on a SQL server. So the last three features that I wanted to emphasize, they are presenter interface, and how the dependency inversion is implemented using this interface as a case in point. Structure of view model. What components do I put usually in a view model, and they all are here to display. And the other interesting aspect is the usage of data template and the content objects. Right, so let's go through these features one by one. The first one is the concept of presenter. Presenter, we see here that we're looking at the view model source code, and it has a field that is called presenter. That's injected field, so it's a part of dependency injection. Let's see what it looks like, okay, where is our constructor? So in the constructor of the view model, we see that it has a processor. This maintains the database exchange. So these are our processor. This is presenter. Its iPresenter is an interface that is defined very high up the hierarchy right here in the core lib. Now we have Excel master. This is responsible for Excel import, export, and we have CSV. This report, I already mentioned that I put it here, but I'm not using it as of yet. Now, when at which point is this presenter injected in the container? So let's take a look. It is injected into container inside the WPF project, inside this assembly. So again, the interface is in here, it is used in here, it is injected in here. So this is the very pure implementation or usage of the design principle of the dependency inversion of an inversion of control, but it's I in a solid. The specific implementations do not depend on each other, but they rather depend on the abstractions. The abstraction comes here in the form of the I presenter interface. The reason it's done this way because only WPF projects can operate the visuals. It can pop up the file, the dialog, it can pop up the tooltip, it can pop up the confirmation message box. So visuals can only be operated at the level of a presentation assembly. Yet the logic that pops up visuals is not in a presentation assembly. The logic of pop-up visuals is in a view model. So when we execute the on task command, and the view model determines that the command cannot be completed, it asks presenter to show notification of an error type. That's what makes it red and puts the funny word caramba in front of it. So the reason view model can operate upon that is because at the beginning when we were registering things in the container, the main window class was nice enough to inject the implementation of this interface into container. And this is seen right here. That's an inversion of control at its best. Next, let's stop and take a look at the structure of a view model itself. So this is a view model for the whole application. It implements observable object class from MVVM Lite library. And what does it have? It has fields, properties, these are bound properties, observable collections, commands. That's about it. View model also can have service dependencies, which it does. So if we look at the constructor of this view model, we will see, or I already showed this. So these are dependencies on the external properties. But that's about it. View model should not, and it should not have anything other than this four classes of items: properties, observable collections, commands, and service dependencies. And in this case, it does not. So in this particular implementation, the things are kept clean and simple. In the last coding feature of WPF, which I wanted to again concentrate attention upon, is data template. If we look at the code of our drawer control, we see that drawer has this navigation items, which are on the left. This is navigation panel on the left. And it has the content view, which is the content view on the right. But what constitutes the content? The content is, there is a dependency property content that is bound to observable property of a view model. So that seems all logical enough. View model supplies the content, and it's absorbed by dependency property of Syncfusion drawer content view. But how does it all work? And what type is does this property have? This property is of a type of object. It's right here. So here it is in a view model. View model sets this property, and the event is fired, and this way the content view knows that it needs to refresh the content. Where is the code? Where is the XAML for the content visuals? The XAML for the content visuals is here. So this is the merge dictionary in a window resources, which is pointing to something that is called data template, right? So this is the data template markup XAML, and that data template is something that displays all the grids, buttons, menus, activates commands, what have you. And I will switch to cursor. So when we look at the code of it, and what we see that the first line in data template markup is data type. So the data template is data type sensitive. We assign that property of a type of object to an instance of a class of some specific type. And in this case, this class of that specific type is defined again in a view model assembly. So we look at the project content and static content. Of course, we had adjusted two navigation items, projects and static. So the last little piece, let's see if I can switch and show it again. So on the commands, once the resolve content command is fired by clicking navigation item, this content observable property is set to an instance of certain class. And the classes are, of course, properly named as static content and project content. And that's how it's all gets together. So that's how we have this this application displaying the sizable chunk of a markup, XAML markup, depending on which type of content we choose. So this is it, my friends. This is about all I could convey within reasonable time regarding the WPF techniques and the WPF demo projects and how it all fits into the framework that is used by Clio Research and myself when customer products are done. This is not a customer product, so I could tell anything you want to know about it, up to the very slight details. Thank you for your attention and consideration. Goodbye.